So there's two ways you can graph a piecewise function. If you're writing with pencil, you can graph all of this graph and then just erase the part that you do not want. Or you can start at the cut point. I call it the cut point, just like we cut our little flip book. You can start with that number and just work your way to the left or work your way to the right for numbers you're allowed to plug in. I tend to start with the cut point. Do you see how this one is 1? You have to imagine cutting your graph at 1 right now. You're not going to actually cut the paper this time, but can you use your imagination and imagine cutting the paper right here? Okay, that's what's going on. So the first thing that we're going to do is plug in 1. We're going to plug in 1. And right off the bat, I usually get some resistance about that because people will be like, Miss Cole, you can't plug in 1 because there's not an equal to. And if you were thinking that, good job. We can plug in 1. It just means what kind of a circle are you going to put? Open circle. Okay. So we are going to plug in 1, and I'll make a little table just so that you can see what's going on. We are going to plug in 1. It's just there's going to be an open circle there. Okay. So let's see what we get when we plug in 1. 2 to the power 1. 2 minus 4, negative 2. So you're going to put an open circle at 1, negative 2. Now here's where I would be like, hey, let's try another number. And if we started at 1, it's tempting to go to 2. Why? Don't write this. Why can I not plug in 2? You can only plug in things smaller than 1. So if we plugged in 1, what else could we try? Yeah, 0 or negative 1 or negative 2. Let's just do 0. And usually I like 3 points, but that'll be good enough. I don't want to go into the negatives. 2 to the 0 power. 1 minus 4, negative 3. So you get 0, negative 3. And then we can't really do any more points, but where should there be an asymptote that we can dot in? Why is it negative 4? Because that's correct. Down 4. Perfect. So you can dot that in, and what you get is part of a swoop. If it was the entire swoop, like it would be the whole thing, we literally amputated it. We cut the graph off at 1. If you were to keep going, it would do this, but we just stopped it at 1. Think back to your flip book. It's like we just did that first piece. Are you with me here? Okay. Now this, just 3, would be a horizontal line at 3. And so you can draw in the whole way across if you want to, and then just erase the part you don't want. But you want a flat line at 3, but only from this cut point 1 and onwards. So you're going to start at the point 1, 3. Oh, and what kind of circle? Why is it closed? Or equal to. Okay, so you're going to start at 1, 3, closed circle, and it's just going to be a constant function at 3. It looks kind of like a clock hand. And that's the graph. Okay. Is it continuous or is it discontinuous? So we're going to say discontinuous, and you can abbreviate for me. Discontinuous at x equals what? Because it's only discontinuous at one place. Where is it discontinuous? 1. Good job. Discontinuous at x equals 1. Now, the other thing you need to be able to do is evaluate piecewise functions. So I'm going to just throw out a couple of numbers, and we'll look at the graph and evaluate them. So if I ask you for f of 5, I'm just going to throw out a few, and we'll just see if you can get it. What you're being asked for is the point 5 comma what? So you would find 5 on your x-axis. Where does that hit the graph? 3. We'll just do this verbally. What would be f of 6? 3. And what would be f of 7? 3. And f of 99,000? 3. Because it's constant at 3 forever and ever. All right. How about f of 0? That means the point 0 comma whatever. You want the something. Do you see how it's negative 3 right there? I'm pointing to, I don't have a better answer than look, it's that point right there. So negative 3. And then we'll do the tricky one. f of 1. That's tricky because it's the cut point. Why is it 3 instead of down here? It's where the closed circle is. Okay, let's try it again. We're just going to practice. What did I put? 5 questions on here? Gonna be just fine. All right. Where is the cut point for this one? 3. So I'm going to start by plugging in 3 to this first function. Here, we'll make a little table. If it helps you to have a table, put that. We're going to plug in 3. Is it going to be an open or a closed circle? Closed. Good. So let's plug in 3. Ready? 3 squared. 9. Good. 8 minus 9, -1. So we get 3, -1, closed circle. Can I plug in 4? No, why not? It's more than 3. So I have to go the other direction. So let's do 2. If you plug in 2, what are you going to get? 2 squared is 4. 8 minus 4 is 4. So 2, 4. How about if you plug in 1? 1 squared is 1. 8 minus 1 is 7. So 1, 7. And I'm not going to put this 1 in my table because I think we could probably just do this mentally. What do you get if you plug in 0? 8. And what shape should this be? Quadratic. It's a parabola. It's a U shape. I'm trying to save you some work. If you know it's going to be an upside down U shape, you can take these points and reflect them to the other side. And that just saves you some work. So it's going to look like this. And so it's a parabola that we amputated. Like you literally cut it off at 3. So this side should have an arrow. It goes on forever. And then the other side, it stops. Closed circle. Now, when you do the second piece of it, you're still going to plug in 3. I get this all the time. Like, you can't plug in 3. I'm like, you can. You're just going to put what kind of circle? Open. Good. Okay. So if you plug in 3 to this, what do you get? -1. So at 3, -1. Oh, what happens at 3, -1? So that means the 2 pieces connect. It's going to be like when we messed around with our flip book and we made them connect. Okay. So 3, -1 is right here. You can't put an open circle on top of a closed circle. Okay. They just link together. And then you would want to keep going. So let's try and plug in 4. 4 minus 4, 0. So 4, 0. And then hopefully like your slope instinct would kick in. Do you see how there's a slope of 1, like 1x, up 1 over 1? Like if you can count to 1, you're good. So continuous or discontinuous? It's continuous. You can abbreviate. Now, if it's discontinuous, you have to say where. Like discontinuous at x equals whatever. If it's continuous, it's just continuous. So you don't have to say that. But then I want to ask you, and this is the last one I'll do this on, because it's on your Delta Math. You have to be able to evaluate these. Like find where that point is on the graph. So if I say f of 6, what you're going to do is count over here to 6 on the x-axis. 1, 2, 3, 4, 5, 6. Where does that hit the graph? 2. Do you see how you have the point 6, comma 2? She's basically asking where that point is. How about f of 4? Find the point 4, comma whatever. It would be 4 what? For 4? 3. Oh, it is 0. I counted wrong. 4, 0. Good job. Just find the point on there. I counted wrong in my head, so I was expecting a different answer when you said 0. I was like, that's not right, but you're correct. You just all right. Where is the cut point for this one? 3. You have to imagine it getting cut at 3. So we're going to start by plugging in 3. What kind of circle will this first part of it get? Open, right? Not an equal to. Here we go. 3 plus 5. 8. Good. Cube root of 8, 2. 2 minus 1 is 1. So at 3, 1, you get an open circle. If you are awake and talking to me, I am so thrilled. All right, what other numbers can we plug in? We did 3. What else can we do? 2, 1, 0, like everything to the left. I'm not sure 2 will work. It might need to be a negative number. I think we're gonna need to go out to -4. Because what would -4 plus 5 give us? 1, right? Cube root of 1 is 1, and then 1 minus 1 is 0. So -4, 0. I feel like I missed one though. Oh well, let's keep going. After -4, we could do -5. Oh, that's it. We just didn't go far enough yet. My brain did something fuzzy. This went left 5, so we're gonna have to go all the way to -5 to get the center. So if you plug in -5, -5 plus 5, 0, and then 0 minus 1 is -1. That's where your center is. So that's where it's gonna wiggle. It's gonna do something like that. I was like, but we had to go so far. That's because it went left 5. So it shifted really far. So it's that sideways wiggly thing, but again, we just amputated it. We just cut it off at 3. The second piece is going to be really easy though. What do you put if it's just a number? Yeah, draw a constant at 4. What kind of circle does it start with? Closed. So you're going to start at 3, 4. And then just a constant line, like a clock hand. Although no one uses those kind of clocks anymore, so. But you know what I'm talking about. All right, continuous or discontinuous? Discontinuous at x equals. So you have to say where? 3. Okay, cool. We'll have plenty of time. Go ahead and flip over. Is discontinuous at x equals 3. Oh, this one has 3 pieces. You see that? You'll be okay. First one, we're going to start at 1. I'll make a little table for us. What kind of circle will we put? Open. Good. If you plug in 1, 1 cubed is 1. Just make it be an open circle. Now, what kind of other numbers can you plug in? Less than 1. So smaller than 1, be like 0, -1, -2, continue on. All right. So if you plug in 0, what do you get? Yeah, 0. And if you plug in -1, -1. -1 cubed is just going to be -1. And it's going to be this wiggly kind of thing. It's actually your parent function for cubic. It didn't even get shifted at all. We just cut it off at 1. And the next part's kind of interesting. It just says x equals 1. That means you just have the point 1, 2. That's all that is. It's like a floating point, 1, 2. So you're just going to put a closed circle there, and that's all that is. It's just when x equals 1, your output is 2. It's just the point 1, 2 is all that is. And then we're going to do this last one. You still plug in 1. It's just going to get an open circle. So you're still going to plug in 1. All right. 1 minus 1. 0. Square root of 0 is just 0 plus 3, 3. So 1, 3, and it's going to be open. And then what kinds of other numbers can we plug in? Yeah, bigger than 1, right? So let's try 2. 2 minus 1. 1. Square root of 1 is 1. And then 1 plus 3 is 4. So 2, 4. Yeah, and it's a square root function, so it's going to kind of do something like this. I'd like one more number we can plug in, though. You might have to skip a few to get to something you could actually square root.
5.
Good, let's do 5. 5 minus 1. 4. Square root of 4. 2 plus 3. So you're already getting way faster and more efficient with that. So 5, 5. So it'll do something like that. That's a cute graph. It's about as complicated as you can make it. Everyone always wants to know, like, how hard is this going to get? That's about as hard as I can make. Continuous or discontinuous? Good. Very discontinuous. At x equals 1. The at x equals part you're going to get right because it literally says 1 right here in the problem. Like, if you're even paying attention slightly, you're going to get it. All right, and then here's our last one. Where's the cut point for this one? 0. You have to imagine cutting the graph at 0. So first we want to plug in 0. If you plug in 0, you will get 0. What kind of circle? Open. Okay, so 0, 0 on the origin, open circle. And you want to graph it less than 0. Watch me point to this because I'm going to save you some work. We don't really need to make a table for this. I want my graph to be over here. What is the slope of this? -1. So it should look like this. Do you see how when I dot in those, it's going down 1 over 1? Are you noticing that? Like if you connect those down 1, okay, I'm seeing heads nodding. Cool. So it's going to do something like that. You can, of course, always make a table. I'm just trying to save you some work. That's all. Now, the other part is from 0 onwards, and we're going to put a closed circle. So look what happens here. If you plug in 0, you get 0. And so what happens to this open circle on the origin? What's going to happen to that? Yeah, it becomes closed. It's going to get filled in. If they link up, it's going to get filled in. And what's the slope of this part?
4.
Yeah, +1. This one was -1. This is +1. So you can go up 1 over 1. And you should hopefully be like, holy cow, look what that turned out to be. Because what is that? It's your absolute value function. So this is actually another way to write an absolute value function. It's a piecewise function where this half has a negative slope and that half has a positive slope. Do you remember how I've always been telling you to use that number out front as your slope? This is why you're able to do that. I'm going to say this on the video as well before I hit stop. I had space on the paper here, so I wrote what your next quiz is going to be about. It's not next time, though. It'll be the time after. Did that message just get delivered? Okay, so this is what's going to be on it. I'm just letting you know. I had space on the paper here, so I put it, but it won't be next class. It'll be the time after that.